What's going on, everyone? Welcome back to another episode of the Muscle Memoirs Podcast. Today, it is my pleasure to introduce Dr. Cody Haun. Dr. Haun, how you doing today?
I'm good, man. I'm good. Thanks for having me on.
It's my pleasure. It's been a bit since we did a training or exercise science focused episode, so I know the listeners are going to be very excited to see this pop up in their feed, an episode with Dr. Cody Haun. But for those who might not be already familiar with you, Dr. Haun, can you provide us with a little bit of background about yourself?
Sure. So, name is Dr. Cody Haun, and I did a bachelor's and master's degree in exercise and sports science at East Tennessee State University, and I was a strength and conditioning coach there and a personal trainer for a number of years, and got really interested in the physiology of training and how body systems adapt to exercise and nutrition. And that led me to do a PhD at Auburn University with Dr. Mike Roberts in the Molecular and Applied Sciences lab there at Auburn. And I spent a lot of time reading about muscle and collecting muscle samples and blood samples and trying to help us understand how muscle adapts to resistance training and different supplementation strategies, and also what are the physiological differences between people that seem to respond really well to resistance training and people who don't, and what we can do about it. So that led me to take a researcher and professor job at LaGrange College in Georgia. So I was there for a couple of years teaching courses in nutrition and exercise science and doing some research. And more recently, so this year, I decided to transition out of full-time academia and start my own lab and do research, primarily like single subject design style research, to help more people fine-tune their own diet and exercise to achieve the best results that they can. And so I'm doing a good bit of coaching and research now, and spending more of my time reading papers and writing rather than grading a lot of exams and things like that. So I'm spending more of my time digging into the literature and trying to put out more content, more free content. And yeah, I'm writing for the Weightology Research Review, so that's exciting. That's been a more recent change. And yeah, I'm having a good time, man.
When it comes to guests for the Muscle Memoirs, you fit the bill. I don't think you could fit it any better. I mean, when we look at what you're doing as far as being an esteemed researcher, being a coach, perhaps most importantly, being jacked. You're covering all facets here. I'm a follower of your weekly emails where you're putting out some fantastic content for free. I'm also a Weightology subscriber, so I'm a huge fan of your work and your writings, and it's really exciting to have you on today for this chat.
Well, thank you, man. I appreciate that. I wouldn't necessarily call myself jacked, but I'm trying. I'm trying. I've been able to build a little bit of muscle and get pretty fit, but still working at it, man. It's a lifelong journey of trying to manifest my best self, I guess. So I appreciate the kind words, though, man. And I'm glad to hear you're subscribing to the Weightology Research Review and you're reading those weekly emails, man. That's cool to hear. I appreciate the support.
For sure. A very modest reply from yourself, but for the listeners, we'll link Dr. Haun's social media, and you will see that he is most definitely jacked. But we have a deep dive into the exercise science literature today for you, dear listeners. And I think a reasonable place to get started is just what's going on in regard to recent publications. And something that caught my eye was in the past 2 weeks or so, a trial came out looking at the efficacy of performing a maximal strength phase of sorts. This was sets of 1 to 3 reps for 3 weeks before completing a more traditional bodybuilding hypertrophy resistance phase for 5 weeks, and that consisted of sets of 8 to 12. So they looked at this group who had the maximal strength phase and compared that to a group that was only performing the hypertrophy training, and they saw some significant, maybe not in realistic terms, clinically meaningful, right? But in regards to research and the time frame utilized, there was significant differences in muscle thickness between groups, and there appeared to be a benefit to utilizing this maximal strength phase. And that caught my attention because this is something that a lot of us who have been practicing this field for a few years now and have been following the science, we haven't had a direct trial to showcase the potential positive effects of this approach, but people have been using it nonetheless just due to mechanistic reasons, and it does seem logical that there could be a performance benefit. But Dr. Haun, I'm sure you're familiar with this study. What were your thoughts? What did you take away from it?
Yeah, so Carvello et al., I think is how you say the last name of the first author. I read that. I know that you had sent over that you were interested in chatting about it, so I dug into that paper. Yeah, I mean, it's an interesting paper, interesting design. The first thing I would say that, like, some things that I liked about the study design, I think there were 26 subjects, and they did a 3-week lead-in training program, which was, I think, important. I think we'll also talk about some limitations of some of the research in the field, including my own. But one thing that I think was cool about this study is they actually had the subjects, they at least asked them to, which is a limitation. They asked them to do the same training program for 3 weeks leading into the study. So it was twice a week of 4 sets of 8 to 12 reps on the leg press and the squat. And they used a load that was theoretically as heavy as they could lift in that rep range. And I think that the sets were separated by 1 minute of rest during those 3 weeks. And then, to your point, they had the subjects, and they also matched the subjects in pairs based on baseline vastus lateralis muscle thickness. So they used an ultrasound and measured their vastus lateralis muscle thickness, so muscle of the quad, and balanced the groups according to baseline muscle size, which is, I think, a strength of the study. And one group trained with what they called a hypertrophy-oriented training program. So it was 4 sets of 8 to 12 reps and with 1 minute rest, just like the lead-in, and that was twice a week on the leg press and the squat, and they did that for 8 weeks. That was the hypertrophy training group. And then the other group they called a strength training oriented strength training and hypertrophy training oriented group. So they did 3 weeks of strength training. They called it strength training, so maximal strength oriented training, and it was 4 sets of 1 to 3 reps. So with the heaviest load that they could handle in that weight range. And they did that twice a week for 3 weeks. And then for the final 5 weeks of the study, they did the same training program as the hypertrophy-oriented group. So the 4 sets of 8 to 12 with 1 minute of rest. And I should say in that 3-week strength phase, they had 3 minutes of rest between each set, and 5 minutes of rest were provided between each exercise. And then they measured muscle thickness after week 3, and they measured it again after week 8. And they also measured 1 rep max after week 3 and week 8. And what they found is at the end of the study, after the 8 weeks, the group that did the strength training and the hypertrophy training, so the 3 weeks of strength work prior to the hypertrophy work, they ended up gaining apparently more muscle mass. But I think a more appropriate way of thinking of that is the ultrasound muscle thickness increased more in the group that did the strength training and hypertrophy training. So we've written a good bit about this. The nature of the measurement to measure muscle growth is a bit nuanced. Like when we refer to the construct of hypertrophy, we're talking about muscle growth. And there are several ways to measure it. A lot of studies will use ultrasound. Some will use a DEXA scan or MRI. Rarely MRI because it's so expensive. And that's considered to be a gold standard measurement of muscle mass. But then we often would use muscle biopsies where we would actually remove a portion of muscle tissue and cut it into thin slices and stain it with antibodies and look at it under a fluorescent microscope to see changes in the sizes of individual muscle cells, which I think is more of a direct measure. And then when you zoom in further, right, we were able to measure myofibrillar versus sarcoplasmic protein concentration. And with all of that said, because that was a little bit hand wavy, the point is that hypertrophy can be concluded from a series of different measurements, and they don't always agree with one another. So one limitation of the study is that there was only one measurement of muscle hypertrophy, and that was ultrasound-derived muscle thickness. And we've found, among others, that muscle thickness and changes in muscle thickness don't always agree very well with changes in muscle fiber cross-sectional area, which I think is a more direct measurement of quote-unquote hypertrophy, right? Where you're actually looking at the individual muscle fibers. Now, to be fair, one other positive about this study is that they actually reported test-retest reliability statistics from the person who did the ultrasound measurement. And so I want to say that the typical error of measurement was 0.01 centimeters. And I think that the coefficient of variation was less than like 0.5%. So pretty reliable. So I think we can be reasonably confident that they did a good job measuring the thickness of the vastus lateralis. And yeah, man, they found that the group that did this strength training before the hypertrophy training, probably a better way of thinking of that is the group that lifted relatively heavier loads for lower volume before they lifted relatively lower loads with higher volumes. The group that did that seemed to gain more muscle mass than the group that did hypertrophy-oriented training the entire 8 weeks. And the subjects reported around 4.5 to 5 years of resistance training experience on average. And to participate in the study, they had to have, they had to be able to squat at least 1.5 times their body weight for a single. So, I mean, I think that they were pretty well trained. And yeah, it's interesting. So, I mean, that's like an overview of the study. And I suppose that you would like for me to provide some more thoughts on why I think that happened. Or did you want to clarify anything?
No, I appreciate that nuance, and I know the listeners will as well. Yeah, let's get into these potentially positive findings. I wrote a little summary about this and posted it on social media, and I had a response from another person who basically put out the question of how do we explain these positive findings, and the two primary hypotheses to this could be that, well, the group that utilized the strength phase, they were able to accumulate more volume load during the hypertrophy phase. But then also there's this notion that perhaps there was some resensitization of hypertrophic pathways from the low volume training. And, I can't say for sure. I don't know if anyone can say for sure what happened. You can kind of help us, elucidate these details. But when I look at this, perhaps if we were just to consider these 2 points, I would slide more toward the fact of potentially the results being a product of being able to accumulate more volume load during the hypertrophy phase, because as far as the research goes on the ability to resensitize beneficial pathways, I'm not too familiar with it, but from my understanding, there might not be a lot of direct research on this. And if we do look at a trial that sort of studied this in some respect, it would be the Ogasawara papers that people have been referencing a lot during these COVID times, and that was the subjects who trained for 6 weeks and then took 3 weeks off, and then repeated that cycle, and they saw that these 3 weeks of detraining weren't there wasn't a negative effect on skeletal muscle hypertrophy outcomes, but there also wasn't a positive effect. And to me, I would think that if resensitization was potentially such a powerful factor, what would resensitize these pathways better than not training at all? And if there wasn't a benefit from complete detraining, would there be this this resensitization effect primarily influencing the results from low volume training? So I guess kind of tease out those details for us.
Well, I will try. I think that, well, I know actually that the reported total training volume in the group that did the hypertrophy training the entire time, so the 4 sets of 8 to 12 reps throughout the 8 weeks versus the group that did the strength training and the hypertrophy training, the total training volume load was higher in the hypertrophy training group. So I don't think that it's volume load mediated. I think that it has more to do with the ability to recruit more muscle fibers. And that's speculation. They didn't measure that. So again, that's another limitation of the study. The results are what they are, but in terms of why, like how did it happen and what were the underlying mechanisms, that's really what I like to nerd out on. And I think that the more we understand those mechanisms, the more that we can defend and justify and logically construct training programs. Right. So with that said, I think that one of the mechanisms is related to an improved ability to recruit more muscle fibers. So in general, if we lift heavier loads for a period of weeks versus noticeably lighter loads, we would expect to get stronger lifting the heavier loads. And indeed, in this study, the group that did the strength training and the hypertrophy training improved their 1 rep max in the back squat and the leg press, more so than the group that did the hypertrophy training the entire time. So their strength improved more than the group that did the hypertrophy training. Well, what are the mechanisms of strength? What are the mechanisms of improving strength? So from a neural perspective or a nervous system perspective, I would say that motor unit recruitment is one of the key ones. So an improved ability to recruit motor units, and motor units are alpha motor neurons and all the muscle fibers that they innervate. So think of it as a nerve that innervates a certain number of muscle fibers. And let's just give a hypothetical example here. Let's say you have the entire vastus. I'm just going to throw out some numbers here. The entire vastus lateralis has 100 motor units, and at the beginning of a training program, you're able to recruit 60, and then at the end of the training program with heavy loads, you're able to recruit 80 or 90. Versus with light training or light load training, perhaps you don't see an improved ability to recruit motor units. And so maybe you increase your ability to recruit motor units from 60 to 65 or 70. And so really, what does that mean? Well, if you recruit a muscle fiber to contract, then, and the muscle fiber contracts, it's the tensile forces that are experienced by that contraction, by the fiber itself, that the cell seems to really respond favorably to. And that's one reason that resistance training is so effective at eliciting muscle growth. It's the tensile forces that the cells experience in response to contraction and stretch under load. That seems to be the primary driver of muscle growth. And so if these individuals that did the strength training before the hypertrophy training and were better able to recruit their motor units, and there's some other neural related effects like rate coding and synchronization. So once the motor units are recruited, then how frequently in a certain time frame are they recruited, and how are you synchronizing the firing of different motor units that would result in a coordinated movement and allow you to execute a task. But in general, if more muscle fibers were being recruited by the individuals that completed the strength training before the hypertrophy training throughout the hypertrophy training period, that last 5 weeks, and even part of the time during the first 3 weeks, right? So they called it strength training, but it's not like that training didn't induce a certain level of mechanical tension. Now, I think that the percent improvement from week 1 to 3 in the strength training group was like 1%. So from week 1 to 3, and in the group that did the hypertrophy training from week 1 to 3, it was around, I think, 2.5%. So not as much during that time period. But then when they started doing the hypertrophy training, that's where it went from, I want to say, up to 6.5% was the final percent change in vascularis muscle thickness in the group that did the strength training and the hypertrophy training, and it ended up being about 4.5% in the group that did the hypertrophy training the whole time. So there was a big jump from week 3 to week 8. And with all that said, I think that the subjects that improved their strength more, so the ones that did the strength training and the hypertrophy training, were better able to recruit the fibers overall in muscle. And the recruitment of those fibers resulted in the experience of those tensile forces, which seem to be the critical signal to elicit an increase in muscle protein synthesis. And so another example, if, let's say, an average number of fibers that were recruited per repetition per set in the last 5 weeks of the study for the subjects that did the hypertrophy training the entire time was 60 out of 100. And in the group that did the strength training and then the hypertrophy training, perhaps it was 70 to 75. And so they were recruiting more of their fibers, and particularly those big, strong, fast twitch fibers. You know, the ones that have more of the myosin heavy chain 2A and 2X proteins and other characteristics that, tend to result in them contracting faster and with a little bit more force. So I think that that's one of the main reasons. I don't think that we can be confident that it was a resensitization effect, but it could have been.
I love that insight, and I really appreciate your thoughts on it. Since we are speculating here for the most part, if we were to consider long-term outcomes, so over the course of a year or some sort of extended macro cycle, incorporating these brief periods with lower repetitions and higher intensities, would you think that if there was a positive effect in the long term, it would still be related to perhaps regaining neural efficiency every few blocks? Or would you then begin to speculate that it could be due to something else regarding resensitization or being able to make your hypertrophy training, quote unquote, more effective by being stronger?
That's a good question. I don't know the answer to it, but I would. Well, we just need to do more work on the whole resensitization thing, man. I mean, it's intriguing. I've talked about it before. The limited amount of research that is available on it would suggest that there's something to it. But you mentioned the Ogasawara trial, right? And you could call that a resensitization effect, but the subjects that took the 3-week detraining periods didn't end up gaining more muscle than the subjects that just continuously train. Now, they were able to get to a similar endpoint, but they didn't gain more, which is kind of the point. If you're going to do a resensitization phase, the idea is that you could resensitize those anabolic pathways to gain more muscle mass, right? If they're very desensitized, and you're training really hard, but it's not getting you the best bang for your buck, the idea is that you could take a brief lower volume period and resensitize the pathways that result in an increase in muscle protein synthesis from training, and somehow get larger gains over broad time. But the reality is we don't have much data on it, man. I mean, there's a rodent study from Ogasawara that would suggest that detraining does appear to resensitize some of the signaling, the phosphorylation process of some of the proteins that are involved in the mTOR C1 signaling pathway, which that seems to be like a main convergence hub of anabolic signals in muscle cells. And so there are proteins that ultimately can activate the activity of mTOR C1, and eventually that manifests as an increase in the synthesis of muscle proteins, which is the process of translating messenger RNA into proteins. And so they took a look at certain signaling proteins that are activated that would eventually increase the activation of mTOR signaling and theoretically result in an increase in muscle protein synthesis. And with a period of, I want to say they used 14 days of detraining after a period of resistance training, they saw a resensitization in the phosphorylation response for P70S6 kinase, which was the signaling protein they took a look at. With that said, that's one study in rats that lasted a few weeks. Do we want to hang our hat on that and take multiple weeks off from training based on the phosphorylation status of a single protein in muscle cells of rodents? I don't think so. I just don't think that there's enough evidence to really prioritize those with a strong opinion on the matter. I'm not saying they don't work. There are very smart people that have gained a lot of muscle mass using them, and we just don't know from a scientific perspective. My guess is that they're probably a good idea. I think that this study is an example of how one could work in practice. We, like for my clients, often that do multiple months of more hypertrophy oriented training, I will have them perform a lower volume period with relatively higher loads, similar to the design in this study. Now, something I guess we'll talk about as far as limitations in study designs, right, is I don't have clients doing 2 days a week of training with just the leg press and the back squat. I'm not, throwing shade at the design of the training protocol in the study, because when you set out to do a study, it's not to present to the world the ideal training program for people to do themselves. It's to answer a specific question, and you have to control for certain things. So that's, why they designed the study according to how they did, and they supervised the sessions, and it's very difficult to pull these studies off, man. But I'm kind of rambling now. I went all over the place, so reel me back in, man. Did any of that make sense, or was that helpful?
It was extremely helpful. I was actually going to follow up by asking you, regardless of what exactly is going on, if you felt this was an efficacious approach for physique athletes, and if it was something you used with your clients. So the fact that you confirmed that you did, I think, is really helpful. We already mentioned some of the potential limitations of exercise science research here, and I don't want to play armchair researcher. I've never formally conducted research. I understand how difficult of a process it is, especially when it comes to humans. They're not the easiest species to work with. But from your perspective, someone in the trenches, what do you think are the biggest limitations of exercise science research. So you already touched on the fact that detecting changes in muscle size is extremely difficult, and it varies depending on the technique that is being utilized. Related to that, we also have to consider the duration of these studies and how slow of a process muscle growth is. I mean, if we're taking college students and we have them for a semester, and if they're reasonably well trained, I mean, how much muscle growth can we really expect? And then, are measurement techniques sensitive enough to pick those up? And then furthermore, we can look at these differences in training protocols and what the heck is even training to muscular failure even mean across studies. I'm not completely sure, but when I see protocols that are talking about, multiple sets of 8 to 12 with only a minute rest, I mean, I could maybe get 2 of those into muscular failure, and then I'm probably on the floor and I can't breathe. But with all that being said, tell us what you think, someone who's an actual researcher, what the most prolific limitations are of these studies.
Well, man, first off, I would say that I credit people doing original research. Like, before I critique anyone's work, I want to credit people who are doing original research. It's very important. It's very difficult to do. And I personally would rather have research with several limitations than none at all. So I think that every study has limitations. And the more studies that we get, the more limitations that we can talk about and discover, and the more we can fine tune our designs. And the more similar that training protocols are and designs are and methods are, that provides the opportunity for other researchers to do meta-analyses and systematic reviews, which I'll talk about the importance of sharing raw data, because I think that is a big limitation of some studies, not in design per se, but just in terms of the potential impact and outcomes in the field. If more people would report their raw data, we could do more data mining and meta-analyses and systematic reviews. But yeah, with that said, I just want to credit people doing original research. I think that it's very important. Now, with that said, I think there are several limitations in the research that we do in the exercise science field. As a researcher myself, I mean, I'll talk about my own research just so no one, thinks that I'm talking crap about their work. We did research in mostly undergraduate young men that were trained. You could say they had resistance training experience, and in some of the research we formally screened them. Like for my dissertation, my friend Chris Van and I sat and, well, not just sat the whole time, but we very closely watched their squatting technique and had a specific protocol to test their strength before they could participate in the study. And we included subjects that could squat 1.5 times or more their body weight to full depth. And I think there is utility in, if you're doing a study and train individuals, asking them about their training program and potentially even seeing their training logs if they have them. And there's a study that would be cool to talk about from that I recently read from Scarpelli et al. that took a look at subject training logs and then based the design of their study on the training logs in part. So anyways, I think that's a limitation, right? We have a good bit of research in young men, particularly college-age young men that are untrained or are probably not very well trained, but say that they've been lifting for a year or two, right? I mean, my first couple of years of training were pretty ludicrous, right? I was pulling workouts out of bodybuilding magazines and just doing really silly things. And you can call that a training experience, but I certainly wouldn't have referred to it as logical, like intelligent training experience. And so we don't have a lot of research in well-trained individuals. And I think women are very underrepresented in the scientific literature and in the field of exercise science. There's not a lot of research in women. I think that needs to change. I think that the the duration of studies is often 8 to 12 weeks. Why is that the case? Well, it's not because the researchers are necessarily testing intentionally designing it to be an 8-week mesocycle. It's more related to the duration of the semester, right? And you only have like 16 weeks with the access to these undergraduate students on campus. And so I think that that's part of the reason why. And man, it's hard to draw inferences about long-term training decisions and programming from studies that are 6 to 12 weeks in duration, right? In not very well-trained individuals. So the duration is another one. There's very, very few studies that have went over like 20 weeks. So that's something that needs to change. And something that personally I would like to see more of, considering the state of the current literature and how a lot of people are recognizing that there's a lot of heterogeneity in the response to resistance training, right? We can pull some concepts from the literature and build reasonable training frameworks and progression models, but regardless of the training model that's used and the training program, the design of it in various studies, one thing that I think is very clear from the resistance training research, particularly as it pertains to hypertrophy, is that there's a lot of variability in how people respond. And that fascinates me. I think that it's very puzzling how you can have people that are very similar, at the beginning of a study, and they do the exact same training program, and they respond differently. There are legitimate physiological differences that exist between these people, and I think that we really have to try and figure out what those differences are and how to screen people for those effectively and in an automated way that's efficient, that wouldn't necessarily require multiple muscle biopsies like we would do to figure some of this stuff out. For example, we found in a follow-up study to my dissertation that subjects who had more fast twitch muscle fibers in their vastus lateralis before they completed the training study seemed to grow more muscle, so increase their fiber cross-sectional area more than subjects who had less fast twitch fibers. Well, how do you fiber type someone? Well, we took biopsies. If you have a client, Mike, that is coming to you for training programming and you want to figure out their fast or their fiber type distribution, I don't think that it would be the right move to extract some muscle tissue from multiple muscles of their body to figure that out, right? And then there are other characteristics that are really, as of now, only detectable from an actual tissue biopsy. So we can't really do that in the practical setting. So what am I saying? The more we understand the mechanisms that are determining how well someone is responding to training, whether that be from a genetic perspective, or a hormonal perspective, or the activation of certain signaling proteins in the muscle, et cetera, the more predictive power we get when we phenotype someone before they start training, that could be really empowering. And the more we understand mechanisms that are influencing the response throughout a training program, the more, I think, appropriate decision making we could use to decide when it's time to back off or keep going, right? Like if we were able to practically measure certain biomarkers that were associated with non-functional overreaching or overtraining, and detect it before it actually happens, that would be super cool, right? Instead of arbitrarily constraining a training cycle to 5 or 6 weeks, wouldn't it be cool to set the initial dose and accumulate volume and or intensity and monitor certain biomarkers that seem to be predictive of if someone is beginning to start responding adversely, and then be able to say, all right, well, according to X, Y, and Z variables, it is likely a good idea for us to go ahead and back off and supply some more recovery so that, we can keep you moving along without you getting an injury and just doing a lot of work for no real return on that investment of effort. So what am I saying? I think that one limitation of a lot of exercise science literature is that we have very practical outcome variables with little insight into mechanisms, right? So like a lot of training studies will report changes in 1 rep max or changes in muscle size or some construct of muscle growth, and that's it. It's like, well, that's helpful. I'm glad that the research is happening, but it still leaves us with questions like in this study, right? Well, like, why did this happen? And how could we detect if someone would respond better or worse to this, right? Because the study leaves us asking those questions. And so I think that we need more research where we're really digging into mechanisms alongside these designs like this, right? Where you have different groups that are using different training programs, but we're also including some biomarker monitoring. And man, nutrition plays a huge role, I think, in how well someone's responding to their training. And a lot of studies just don't, and dude, it's hard, right? Like it was very challenging to supervise and consult with a registered dietitian for my dissertation, which we did. And a lot of the subjects just wouldn't follow the guidelines. They wouldn't follow the dietary protocol, and they wouldn't enter their data, right? So, but we need to understand that, right? We need to understand how diet influences how well someone's responding to training. And a lot of studies don't include a dietary control, right? So, or they're not like specifically intervening in the subject's diet. They're typically instructed to maintain their normal dietary habits. So, that's a big limitation, I think, of training studies. Covered a good bit of ground there. So I think it would be important to talk about how we remedy it. Like, what do we do about it? Because it's fine for me to sit here in my car and like complain about the limitations of research. But what do we do about it? I think that's important. As my mentor used to say, Dr. Roberts would consistently tell me, ideas are worthless without execution. And so I have ideas on how we remedy this, but we got to do something about it, right? We have to execute for it to be meaningful for the field. And so one thing that we attempted to do before COVID was a multi-site design for a study where, we have multiple researchers at different universities and colleges that are recruiting subjects, and we're all doing the same program and the same measurements, hopefully in the exact same way. And that decreases the workload on any given single individual site, right? So the burden of recruiting and managing and supervising all those subjects, but also it increases the total sample size, right? And that can improve the resolution and improve the power, the statistical power of the study so that we can draw stronger inferences. So I think that's one example. And then we need more money, man. Yeah. Like, dude, these studies are, especially when you get into measuring mechanisms. And so you're pulling muscle, you're pulling blood, you're doing Western blotting and qPCR, and you're doing immunohistochemical staining and potentially proteomics and transcriptomics and these advanced molecular biology techniques. It's incredibly expensive. And one of the main reasons that a lot of this stuff isn't included is because we don't have a lot of money to do exercise science related research. It's just not a very well funded area, unfortunately. So for all of the people that are complaining about the design of studies, they need to put their money where their mouth is and start a Patreon account or a GoFundMe or something. Maybe I should should do that. But it's hard to get money to do these, man, and it takes a lot of money to do these types of studies. So I think we need money to do these studies, and those are just a couple ideas. I mean, I have more, but what do you think about all that?
I think you need to start a GoFundMe, and I'll be happy to share that with the listeners, and we can all donate towards getting some high quality exercise science studies. That's what I think about that.
Yes, that's funny. Dr. Andy Galpin, he's like a role model of mine in the field. He does amazing research, both deep molecular biology work and practical work. Have you had him on the podcast?
I have not, but I can confirm he's on the list.
Oh yeah, man, he's top notch. But he, I think, actually has a either a Patreon or a GoFundMe that he has persuaded people to donate to do research, which is pretty creative and cool. But maybe that's what it takes, man. I mean, I don't know, but we do need more financial support. My attempt in the meantime, hopefully we will, going into 2021, we will be out from under this pandemic and be able to do more work, do more research with human participants. It's very difficult right now, right? It's challenging with the policies that are set forth in the guidelines to do research, and a lot of places just aren't allowing it without pretty strict precautions in place. So hopefully in 2021 we can get started. But in the meantime, I mean, I'm trying to approach some of the research questions that I have more from a single subject design standpoint, and really carefully controlling training programming variables and nutrition related variables, and doing various tests to measure how someone is responding over time. And it's like one of my grad school professors, Dr. Bill Sands, used to say that if you're going to do monitoring for a client or an athlete, then you have to be monitoring both the dose and the response. So dose of training and the response to it. And, obviously be really careful with how you're taking the measurements and how you're acquiring the data, et cetera. But that's what I'm trying to do now, man. But hopefully we'll be able to start to try to do these multi-center trials, and I'm collaborating with people on trying to pull that off, and getting people involved that are, in and out of academia, and trying to put together something like that where we can do a multi-site study with the same training program and the same measurements. I think that would be really cool.
Yeah, absolutely. I think I speak for everyone when I say really appreciate your efforts to advance this field forward. You touched on so many great points there. I think one path that I want to continue down as we're finishing up this discussion perhaps is the variable response to resistance exercise, but also your comments on including more raw data. I think this is something that's particularly fascinating because you mentioned the Scarpelli paper, which, if I remember correctly, they took into account the subject's training history, and then one of the interventions was they took that baseline volume and just increased it by 20%, whatever that subject's volume was, and then there was just an absolute volume group of something that was relatively high. And then we also have that recent Aub paper, which they looked into the subject's training history. It didn't necessarily influence the intervention, but it was just really interesting to see the results and how the volume that the subjects performed and how that compared to what they were previously doing. And the fact that in the Aub study in particular, there was, in the low volume group, the vast majority of the subjects improved. They saw a positive outcome from the training intervention, despite the fact that it was lower volume than they were previously performing. And I think, of course, the majority of the literature points towards this positive effect of volume on muscle hypertrophy. But the Aub paper and the fact that it's one of very few that takes into account the subject's training history just makes me scratch my head and wonder about just the value of novelty in the training program, or even perhaps maybe these subjects were just training a heck of a lot harder because they were in a study and they were being monitored by researchers. But I'm just curious about your thoughts on that and those studies in particular, taking into account that raw data.
Well, yeah, and I mean, in terms of the raw data, what I'm referring to with studies is when we do a study and we have all of this data in spreadsheets, it's easy to share that with people, right? You can put that online. You can share it with the world and people can access it and they can do their own statistical analysis and inspect your data. I have a lot of respect for people who do that. It's transparent. To me, it speaks to the integrity and the honesty of the research. I picked up on this in grad school, and the more I thought about it, I was like, well, yeah, let's share the data, like all of the data, and people can mine it and potentially find something that we didn't. And so I think that it's important that we move towards that model of sharing all of the data with the world when we do a study, so that whoever wants to access it can. And that could lead to some interesting discoveries that a research team might miss out on. So that's what I was referring to. Now, in terms of your question related to data pertaining to the training history of subjects in a training study, I think that's really neat. One of the issues with that is, so to back up, the Scarpelli paper, from what I can gather from the paper, they reviewed subjects' training logs and attempted to increase their volume by around 20% relative to the recent historical training in their training logs. Now, Mike, do you think that all of the subjects in this study had super accurate, granular training logs?
Unfortunately not.
Yeah, I mean, so I don't know, like maybe they did, but I'm kind of skeptical of that. I think that it's better than nothing, but that's trusting that the subjects accurately reported all of their exercises and the sets and the reps, etc.
I
But if
guess
we
it
assume that
also
they did,
differs in how they. So even if they had a consistent log they're tracking, right? Everyone kind of tracks their volume differently on top of that, right? Like what quantifies as a hard set to that person as opposed to a warm up, and then what they're actually counting as volume. So I guess more limitations, right?
right. But hey, again, I'm glad that the study exists, man. I'm glad they did it, and it's a creative design that's really, really cool. But that's something to consider. Similar to the Carvalho paper that we're talking about, where they had subjects do like a 3-week lead-in program, where everyone did the same program for 3 weeks prior to the study, as sort of like a washout period or an acclimation period, or at least a control, a form of standardization. I think that could make a lot of sense, right? If you are going to do a training study, at a minimum, maybe 3 to 5 weeks of similar training for all of the subjects to remove the potential variation in responses associated with recent historical training, because it almost certainly plays a role in how subjects respond to a certain training intervention. And I doubt that 1 week of no strenuous exercise before a training intervention is enough to wash out some of those effects. And the decay rates of muscle size and strength with detraining are actually pretty slow. And those responses are specific to the type of training that someone is doing. And if everyone's doing a different training program right before a training study, then, variation in the responses that's just simply associated with what they were doing, several weeks before the study started. And we don't want to assume that isn't playing a role when it might be. So I think that would be a good remedy to better understand some of the variability in responses. But yeah, I don't know if I answered your question, but those are just kind of my thoughts on that, like the Scarpelli paper. And what they found, just to clarify for the audience, is that This is within subject design. And so the one leg did 22 sets a week, and the other one did 20% more volume than the recent historical training. And the leg that did the 20% higher volume than recent historical training ended up growing more than the leg that did 22 straight sets a week. So that's pretty neat, right? It's kind of the proof of principle of the overload concept that, overloading training, making training relatively more difficult over broad time is likely a good idea to continue to instigate the adaptive responses that we want. To some extent, that isn't always overloading volume per se. But anyways, those are some general thoughts, man.
Did they post the individual data in the Scarpelli paper? Like, do we know for the fixed 22 set group, like what sort of increase or decrease in volume that was for the subjects?
I would have to go back and look at it, man. Yeah, it's been a while since I read that paper. I do recall, though, that it was 22 sets versus 20% higher in one leg, and it was within subject design. I would have to go back and look at the specifics, though.
Got it. Do you have time for one more question real quick?
Sure.
Okay. My final question for you, Dr. Haun, after diving into the dark depths of the exercise science literature, is that as a practitioner, are there any training strategies that you feel are efficacious for maximizing muscle hypertrophy, but have yet to be validated by the research or even studied at all, really?
Yeah. So one is the importance of variation, especially the more trained that people become. When you look to the research, variation in reps and load with certain conditions. So when volume is relatively sufficient and intensity is reasonable, like above around 30% one rep max, when you look at the research on variation in training program design, like reps per set and load, in general, it doesn't appear to play much of a role, right? With the bulk of that literature, for example, when we look at some of the studies that have taken like 30% one rep max versus 80% one rep max to failure, and over the course of weeks, they'll do that 2 or 3 times a week, and then quantify the change in muscle size, and it's similar. Now, I mean, I think that's one way of looking at it, but a lot of that research didn't quantify protein level changes, which could be different, right? So if we had actually had like biopsy samples and looked at the prevalence of certain sarcoplasmic proteins, so proteins in the fluid portion of the cell versus myofibrillar proteins that are part of the ultrastructure of the contractile apparatus in muscle, I think that loading plays a larger role there than we probably think, or at least we know right now. Like variation in loading, the load that you use regularly in training, I think affects the protein level fraction of muscle. But yeah, so with that said, I think that the literature overall, so speaking to the Weightology Research Review, James has an excellent summary of this research on variation and periodization for hypertrophy. Over on the website, it's for free at Weightology. And really the key takeaways from the article are that, and he reviewed several studies, that variation in load and reps per set doesn't seem to play much of a role in the short term in modulating the growth response to training. But notice I said in the short term, and we go back to one of the limitations of study designs, right, is 8 to 12 weeks. So I think if we had more research over broad periods of time, like 20 5 or more weeks, so 6 months or more of training, and you have a group that trains the same way the entire time and just tries to like accumulate volume each cycle and get to 30 or more sets per muscle group for most muscles, and they do that for like 6 to 8 straight months with no change, no variation, versus a group that interrupts that style of training with like a strength phase or a low volume phase with relatively higher loads and lower reps per set, perhaps for a month or two. I think that would work better than straight high volume training for months on end. But that hasn't really been shown in the research. And this study is an indication of that, I think, the one that we're talking about from Carvalho et al. So I think that's one example. So does that make sense? Like variation in load and reps per set. Another reason for that, I think, is to give your joints a break and break up the monotony of training, like the psychological monotony. I think that there's something to that. Like, a segue into a different style of training can be very psychologically refreshing and can catapult you into another productive hypertrophy training phase. That can look a lot of different ways. It doesn't necessarily have to be a strength phase. For example, like something that I've done over the past couple of years is to introduce more of like a concurrent training program with a lot more conditioning than I normally would, and lower frequency and lower volume for resistance training for a short period of time. That can be a nice change here and there, and it's probably good for your heart to do that every now and then. But yeah, man, I think that the variation concept is important, but it hasn't really been shown to be that important in research yet in terms of for muscle growth. And then another one that is surprisingly contentious, and we just don't know yet, is the importance of metabolite accumulation for hypertrophy, and if it's worth doing entire cycles of training focused on generating a lot of metabolites, so really achieving that burning sensation in muscle during sets. So like marathon sets are very high rep sets, perhaps 25 or more reps per set. Doing that for a period of time, if that works better than training between 6 and 12 reps per set and just adding some set volume each week and trying to add a little bit of load, if you took a group of people and did that for 3 months versus a group that did 3 to 6 months, and then a group that did 8 to 12 reps or so, accumulated some set volume over the course of 5 to 6 weeks, and then had a deload week in there, and they did that for a couple months, and then did a metabolite accumulation based cycle where you really go after generating a lot of metabolites. I think that might be more effective than straight high volume 6 to 12 reps per set kind of classic hypertrophy training, but that hasn't been shown in the research. There is some mechanistic data in rats and in cell culture that would suggest that, for example, lactate seems to be an anabolic metabolite. So when you put lactate in a petri dish with muscle cells in it, they have been shown to grow compared to like a traditional culture medium. So that's interesting. And then when you feed rats lactate, there's a study from, I think that the last name of the first author is Ono, which is really cool, OHNO, and they found that when they fed rats lactate, they increased their muscle size. So I don't know. There's something to lactate, I think, and there are several other metabolites like hydrogen ions that are produced from metabolism, right? That's the definition of a metabolite, a small molecule that's produced from metabolism. So things like lactate and hydrogen ions, maybe that is worth prioritizing at least some of the time during like an annual training program that's focused on maximizing muscle growth. But again, not clear from the research.
Excellent. Yeah, we've had a number of guests speculate on both of those ideas, and I think most practitioners at this point would agree that there's probably some utility to cycling through these periods. Most recently, we had Lyle McDonald on to talk about some theoretical periodization for hypertrophy work, and basically came to pretty similar conclusions. So I think that should increase the listeners' confidence when we have all of these great minds more or less agreeing on these theoretical ideas. We just need the research to kind of pan out these approaches and give us something concrete to confirm these hypotheses. Dr. Haun, thank you so much for your time today. I really appreciate it. This is one that the exercise science nerds are going to absolutely love. Our listeners who want to go learn more about you, go support you, where can we point them toward?
Yeah, Mike, I appreciate it, man. I think you're doing some important work having us researchers on and smart people in the field to help put out good information. So kudos to you. We do need people doing this work, man, and trying to get out good information and share the science, because as a researcher, it's difficult, like we were talking about before the call. I have to force myself. I think it's important to put out stuff more consistently, because when you're in the lab and you're doing research and you're reading papers, it takes a lot of time and writing, right? And so we need to combine efforts and have people sharing the information. And I think it's important work that you do. So I appreciate you having me on, man. And yeah, I would love for people to connect with me. So I'm on social media. I'm on Instagram and Twitter at DrCodyHaun. That's Dr. Cody Haun. And you had mentioned the weekly email that I'm doing. I think I'm having a good time with that. So most weeks I'm reading a study thoroughly and then providing a concise overview in email form to subscribers, and it's totally free. So if you want to stay updated on some research, you can sign up for that to receive that at my website or on my link tree that's on my social media accounts. It's the top link in there. And then I'm writing for the Weightology research review. I think that's really cool. So with Dr. Brandon Robertson and James Krieger, we're putting out a research review every month where we're taking a deep dive into a study and then providing you with some really practical take-homes. So things related to muscle gain and fat loss and training and lifestyle. So that's cool. And what else? Yeah, connect with me on there, and let's stay in contact and let me know what you're interested in, and I'll keep trying to put out helpful content, do helpful research.
And all of those links will be in the show notes. I highly encourage everyone to check those out and get yourself some brain gains. But that does it for another episode of the Muscle Memoirs Podcast. Thank you so much for listening, everyone. Hey guys, Mike here. If you're interested in learning more about how to maximize your health, body composition, and performance, head over to hammerawayfitness.com, where you can sign up for coaching or even just schedule an hour consult with me to get some of your training and nutrition questions answered. Also, if you enjoyed this episode as much as I did and would like to further support the growth of the Muscle Memoirs podcast, you can give a donation to the link in the show notes, leave us a review, and or share this episode with your friends, whether that be dropping the link in a group chat or putting a screenshot in your Instagram story. I truly appreciate it.